This video will be the only MQL5 tutorial you will ever need. Stop searching for gurus that can tell you what the next best strategy is. Start taking responsibility for your own trading. So what I will do in this video is I will explain everything you need to know about MQL5 programming. I will give you all the basics. You will learn about variables, data types, data structures, control structures, everything you need to know. Also, I will put timestamps in the video, so make sure that if you have questions later on, you can always come back, rewatch the specific passage in this video. Also make sure to watch the whole video. This is really important because I will base the progress in this video on the previous minutes. So if you just skip around on your first visit here on this video, you will probably not take away anything from it. Make sure to watch it from the beginning to the end. Make sure to copy every line of code that I will show you later on. Make sure to type it on your own. I won't post the code. I want you to learn something because in the long run, this is the only way to really benefit from automated trading and to become independent. Save this video, share it with friends, and also make sure to subscribe to the channel if you want to learn more about automated trading. So why do I know that this video will be beneficial for you? I'm René Balke. I'm an automated programmer, or I'm an automated trader, and I program for over 7 years now. I've done thousands of EAs, multiple hundreds of freelancing jobs for customers, so I kind of know a little bit about MQL5 programming. Also, I'm trading for over 7 years, automated, completely automated now, and I'm profitable. So I hope that I can give you a little bit insight in this world, into this world of automated trading. So this is what this video is about. If you watch it, I guarantee at the end of the video, you will be a better programmer, a better trader, and overall, you will have a much better position when it comes to this race of who benefits on the financial markets. So invest a little bit of time, start learning, and enjoy the process. So let us now jump right into the action and start with the actual programming part. So first of all, let me explain to you what the goal of our automated trading strategy or automated expert advisor should be. So we will be working with the ATR indicator, but you can apply this later on, like all the programming basics and the concept of an expert advisor to pretty much every indicator you want. And you can also use the basics to write pretty much whatever program you like. But in this case, we'll work with the ATR indicator. So if you're not familiar with this ATR indicator and you never used it, let me show you quickly how to find it. In your MetaTrader 5, if you go to the navigator, which you can open by clicking on View Navigator, there you should find the indicators folder. And if you open this, you should find examples. And if you go here, whoops, not this one, you should find the ATR indicator. If you drag and drop it on your chart, you can see this indicator has one input, one value, and yeah, you can of course change the colors and everything, but we won't go into this detail. We will just apply this to the chart, and I did it already, so now I have two of them, but you can see this is indeed the indicator. So what does this indicator do? The indicator ATR means average true range, and it will just it is just a average of the last X candles, in this case, or by default, it's 14 candles of the last 14 bars. So if you see if the last 14 bars, for example, in this period here, if they are rather small, the ATR value will decrease because the average size of the last 14 candles is small. But if the candles start to become bigger, like here in this area, you can see the ATR indicators going up because if there are more big candles in the last 14 candles, of course, the average of these candles, like the average size, will also be bigger. And what we want to do is we want to compare the ATR value to the size of one specific candle, which will be our trigger candle. For example, I highlighted, or I just put some arrows here for some possible entry scenarios that this expert advisor should identify and trade. So we can see here this candle where my crosshair is right now. This is a really big candle, like from open to close. These are 300 points. And at this point, also the ATR is really low in value because the previous candles were rather small. So if we have a candle then that is by a factor X bigger than the ATR value, then we want to enter into the direction or enter the trade into the direction of this big candle. Means if we have a really big short candle, for example here, red candle, with the beginning of the next bar, we want to enter a short trade. And really often you can see, for example, here this trade or this candle would go down like for at least 100 points from the beginning. So really often the previous move will just continue after such a big candle. And I highlighted some more candles. For example, here we had some big candles and we had a small ATR value before. So we can see if this would be a trigger candle, again 300 points, this would be a nice down move. And for example, here again we had another really huge red candle and price was coming down afterwards. And also we can of course see this for green candles. Here we had a really big green candle and the ATR was low, so this would trigger a trade potentially, and this would have been a great trade. So I mean, of course I can show you one or two examples, but not all of these trades would be winning trades, not all of these trades would be losing trades. And actually in this video, it's not really about the specific strategy that we will create, but it's about you learning how to write code in the MetaTrader 5. And this is why I want to teach you everything you need to know to get your first programs up and running. So let's jump into the actual programming now. To write code in the MetaTrader, or for every software pretty much, you need a development environment. And in the MetaTrader 5, we have a integrated development environment, which is in short IDE. So you can click on this IDE button here in the navigator bar if it's visible. If you do not see it, you can also go to Tools and then MetaQuotes Language Editor. If you click on this, it should automatically open the MetaQuotes Language Editor. And this is the program or the tool or the editor pretty much that we will use to write code in. Let me delete some of these programs that I've wrote before, and let's open a new one. I mean, for you will probably not see any program here if you never worked with programs or if you never wrote code for the MetaTrader. For you, this could look blank, but we can change this quickly. Go to the upper left corner of the Meta Editor, and there you should find this new button. If you click it, you can select Expert Advisor, usually it's pre-selected, template, and then you just click on Next. Now you can choose a name for your program, and we can say ATR Breakout YouTube, for example. This would be my name for the program. And then you can have an author, a link and everything, but this is not important for the actual program. Then we go click on Next, and we click on Next again, and then just Finish. And this, you can see this will create a new file. It's a .mqh file, and this is our brand new Expert Advisor. You will also find this file in the navigator of your Meta Editor on the left side if you open the Experts folder. So here we should find the ATR Breakout YouTube program now, which is again a MQ5 file. So if we now go to the MetaTrader, if we go back to the MetaTrader, we can also find the navigator in the MetaTrader. We used this before to apply the ATR indicator to the chart. And here, if we go back, we will also be able to open the Expert Advisors folder. But here we do not find our ATR Breakout YouTube program. And this is because right now our program is just a text file. It's just a text, pretty much. I mean, of course, there are some colors and everything, but the MetaTrader is not able to run this code because it is just a text file that is easy to read for us as a programmer, but not for the computer. So there's one important progress or process in any programming pretty much, which is the compilation. And in the Meta Editor, you will find in the navigator bar at the top, you will find this compile button. So if I click this, we will see some action down here in the toolbox. So let me click this, and you can see ATR breakout.mq file will be compiled and the code is generated, which kind of means that it generates not really the code, but it generates a executable file, which is a ex5 file then. And if we now go back to the MetaTrader 5, now the ATR breakout YouTube program is visible, and we could drag and drop this on a chart. Isn't this great? So we can apply our program to a chart already, and then it is running on the chart. And this is what we are doing now. You can see here, this is the name, the version is 1.0, the copyright is MetaQuotes, whatever. And yeah, we can just click on OK down here, and now you can see in the upper right corner of your chart, it should say the name of the program with this little head sign next to it. This means that this specific program is now running on this specific chart, which is a Euro-US-Dollar 1 hour chart. So if we go back to our code, we can also find the version ID here, which is 1.0, is part of the code. Also, the link and the copyright is also part of the code. So for example, I could go ahead and change this copyright to 2023 and add my name here instead of MetaQuotes Limited. Also, I can use any website here, for example en.bmtrading.de, which is my website. And if I compile the program again with these changes, and if I double click on this little head here in the chart, you will see, okay, it is not changing. This is only changing if we run the program again. So remove it from the chart with a right click and remove, and then run ATR breakout again on the chart. Okay, and it's still not here. This is actually a bug in the MetaTrader, but if you start the MetaTrader again, let me do this real quickly. If you start the MetaTrader again, then we will see the updated value. So there we are. Let's get our ATR breakout YouTube program running again. And now you can see there's the copyright and it's saying Rini Balke. And if I click on it, it doesn't open the MetaQuotes platform or web page, but it opens my website. So this is how we can work with these properties. But as you maybe already imagine, these properties, they are not important for the program itself. So they are just a information for everyone who's using the program. You could use the properties, but you could also delete them. For now, let's just keep them at the very top of our program. Also, what I just deleted is a comment. So these gray lines here, they are comments, which means that these comments are also not really part of the program. So if you compile the program or the code, these comments will be completely ignored by the compiler. So they are not part of the executable. They are just here in the text file because they could hold some information for the programmer, but we can just delete them and it will not change anything for the executable file. So if I just delete all of these gray lines, there's no problem at all. And now we only have these three basic functions left. So I could go ahead and add some comments myself by just adding these two slash signs, and then I can write this is a comment. And now this is a comment, which is completely ignored when I compile the program, which is just there for me as a programmer to tell me, for example, what a function does or what a specific part of the code does. You can also write multi-line comments like this, 1 slash 1 star. This is the start of the comment, and then you can have blah blah blah, and this is the end, for example, and everything between these two signs here is then a multi-line comment. So you can write as many lines as you want, and all of these lines are ignored completely by the compiler. But yeah, let's not use these comments too much because again, they don't really change the program. And what we want to do is work with a automated strategy here. So what do we want to do? First of all, let's talk about what we have left here now since we deleted all of these comments. We have three functions left, and these three functions, they are so-called event handling functions. Usually they start with on, and then there is some specific event name that will trigger this function. For example, the first function here is the so-called onInit function. And this is the onInit function. A function consists of the function signature, which is this first line here, and the signature is made of the return type of the function, which is int or integer. In this case, the function name, which is onInit, and the function parameters. In this case, we do not have any function parameters. We will get into details later on, and I will explain exactly what integer variables or the integer data type is and what parameters are. But for now, it's just important that these event handling functions are called automatically by the MetaTrader. So whenever a specific event occurs, the program will automatically execute this function. And by executing a function, it means that everything inside of the body of the onInit function will become executed. The body of a function is always wrapped by these small curly brackets here. So you can see, this is the start of the body, and this is the end of the body. Everything in between these two curly brackets here is the body of the onInit function. So whatever we write here will be executed when this function is called. So let's add one more function inside of this function, which will be the print function. So if you write print like this with a capital letter P and then just print, and then you open the parentheses of this function, because every function has these brackets, these round brackets after the function name. This is how the program knows that it is a function. And it can have parameters. For example, this print function has a parameter. Here we can, for example, say we want to print a specific sentence, for example. We can print, this is the onInit function, like this. So what did we just do here? We called a function inside of the body of the onInit function, which means that whenever the onInit function is called, this function will be executed because it's part of the body of the onInit function, right? And this print function is a function that does exactly what the name says. It prints something in the experts journal of your MetaTrader 5. So if we go back to the MetaTrader 5 and open the toolbox by pressing Ctrl T or by going to View Toolbox, you will see that there is, we don't need this. There is this toolbox, and you probably know this one. There are the trades and everything, but you also see the history and also the experts tab down here. If you click on this experts tab, we will see everything what this program here prints in the experts tab. So if I compile the program now, we will see this is the onInit function printed here in the experts tab. And this is happening because the program is still active in the chart. And whenever we compile the program, it is initialized again in the chart. There are other events that call this onInit function. For example, if I remove the program from the chart, and if I then search for it again in the navigator, if I activate it again on the chart, the onInit function will be called because it's initialized again. Also, make sure to have a look at the source here. The source always tells us what specific program called or printed this message. So this time it was printed from the ATR Breakout YouTube program, which is currently running in the Euro-US-dollar 1 hour chart. This is important because if I change the time frame, for example, to M15, you can see the onInit function is called again. But this time, if we have a look at the source again, it's called from the M15 chart because it's initialized in this chart, and this will trigger the onInit function again. So much for the onInit function. Also, we will have a return type here, which means that the function returns something, but let's get not into this detail for now. We will talk about this later on when we talk about functions. Also, let me delete these comments here because we don't really need them, because we know at this point that these curly brackets always wrap the body of a function. And let's have a look at the second function here, which is the onDinit function. Again, we will have the signature here, which is this line, which consists of the return type, which is in this case a void. And void is a really specific return type because it kind of means nothing. The function just doesn't return anything. It is called and then it's over. The function is called on dinit. This is the name of the function. And this time we of course have these brackets again, the round brackets after the function name, which means it's a function. But this time there's actually something written in these round brackets, and it's a parameter. This parameter is a constant parameter, which is just a modifier, which means that this variable cannot be changed. And then there is the actual variable data type, which is integer. And we will get to this in a second, but let's have a look at the third word here in the brackets, which is reason. And this reason is the name of this specific variable parameter that is passed when this function is called. So whenever the onDinit function is called, and again, this is an event handling function, so it's called by the program itself or by the MetaTrader. Whenever this onDinit function is called, the body is executed, and we see the body here. So we can add a print statement again. Let's say print. Let's say this is the onDinit function. And the reason is, and then we write these quotation marks. These quotation marks are really important because what we add here is a text value. And again, I will explain this in a second, but for now, just copy what I'm writing here. And then for the print function, we can concatenate multiple values by using a simple comma. So we'll write this is the onDinit function and the reason is, and here we will just add the reason, and this is the exact name of this variable. So we will print whatever is inside of this variable. And then another comma, and then we will add these 3 points. This is of course optional, you don't have to do this, but just to show you that you can add multiple values here inside of this print function. And then again, always make sure to close these round brackets for the parameter list of the function and then end the statement with a semicolon. Like this. This will end the call of the print function. So if we compile this and go back to our program, we can now see if I right click and remove the program from the chart, it would say this is the onDinit function and the reason is 1. What happens if I run the program on the chart again? First of all, of course, it will print this is the onInit function because this function is called. And if I change the time frame now, we can see the onDinit function is called on the old time frame, which was M15 first, and then the onInit function is called on the new time frame. And have a look at the reason. The reason is now 3. Not 1 anymore. And by reading the reason, we can see if it's necessary for our program, what specific reason caused the deinitialization. And you can read about the reason in the MQL5 reference. The MQL5 reference is what you can see if you click on help and MQL5 reference. This is a really important tool if you want to write programs for the MetaTrader 5. Because here you can read everything about this programming language pretty much. So for example, if you go here to index and if you just write a function name, for example onDinit, you will find an entry for the onDinit function. And this pretty much explains everything about this specific function. For example, we will have a list of all the reasons here. And this is great, isn't it? Because we learned that the reason 1 is reason remove, which makes sense because this reason was printed when I removed the program from the chart. And then we have value 3, which is chart change. And again, this was printed when I changed the chart. So everything makes sense now, right? So this is how you can work with the MQL5 reference. Just open it whenever you want to learn something about a function and read the specific entry for it. So now we only have one function left, which is the onTick function. And this will completely spam a lot of code, a lot of prints in the experts tab. If I now add this is the onTick function here as a text. So let's just do this quickly and compile the program again. Let's go back to the MetaTrader, and you can see this is really printing a lot of, this is just spamming the whole experts tab. And this is because the onTick function, as the function is named, it will be called on every single tick, which means if there is a price change, so a tick, this will call the onTick function. So yeah, if you have a print statement like this in the onTick function, it will be really messy in the experts tab. So let me delete this quickly and let's compile the program again. So if we just keep it like this, the experts tab is not messed up, and we can now go to the next step, which is starting to write our actual strategy. So since we are working with an indicator, which is the ATR indicator, a good starting point for your program is to tell your program what specific indicator you are working with. And there is a concept in MQL5 programming, which is working with indicator handles. And if we go here outside of our event handling functions, at the very top pretty much of our program, and if we create a variable, which will be an integer variable, we can name this variable handle ATR, and then we end the line with a semicolon. If we compile this, no error, everything's fine. So what did we just do? We created a new variable. So this is a really simple process pretty much, because we just write 2 words and a semicolon. But what happens inside of inside of your PC, of your machine? So when you run a program and in the code you declare a variable like this, it means that whenever the program is processing this specific line of code, it will create or block a space in the memory of your PC. For example, in the random access memory of your PC, it will block a specific amount of bytes for this variable here. And this is why variable data types are important, because different variable data types, or data types in general, take up a different amount of space or bytes in your random access memory. And you can think about this like this. Like for example, 1, 2, 3, 4, 5, 6, 7, 8. This 8 bits are 1 byte. So for example, we have this is 1 byte now. And in your random access memory of your PC, you will just have a lot of bits. So there are just a lot of bits concatenated together pretty much. And if we have 8 bits, it's a byte. And if we have 8 bits again, and again and again, these would be 4 bytes. And now let's have a look at the reference again. So you will see why I'm explaining all of this. So let's go to help, MQ5 reference, or if you want to do it quickly, you can go inside of the word or the name of the function or whatever you want to search for, and click on F1 on your keyboard, and this will open the MQL5 reference for the specific entry already. So you can see the integer variable is explained here, or the data type. It consists of 4 bytes, which are 32 bits. And this is exactly what we can see here. So this is the space inside of your random access memory of your PC that will be reserved for a integer variable, because we just declared a integer variable. So the program knows at some point we want to store a value in this variable, so we already need to save 32 bits or 4 bytes in the random access memory of our PC. And the name of a variable is pretty much like, for us, it's the name of a variable, which we will use to address this variable. But for the computer, it will just point to this specific starting point in the random access memory where this variable is located. And since it will then know where the variable is located, it can then look at the data type, which is int. So it knows from this point on, we will need 32 bits or 4 bytes, and this is our integer variable, or the value that is then stored or we can address using this specific variable. And this is how variables work in computer programming pretty much, and also in MetaTrader programming. And for example, this integer data type, it can hold values like 2 or 3 or 43 or whatever. Or if we have a look at the reference again, in fact, it can hold all the values from minus 2 billion whatever to the maximum of, yeah, you can see it here. So these are the boundaries in which we can choose any value pretty much and store it inside of a integer variable. This is which we can use the integer variable data type for. So for example, there are some more data types that could be interesting for programming in the MetaTrader file. So let me explain the most important data types to you quickly. So we learned about int already. The integer data type can hold values like 2 or 3 or something like this, or also something like this. Then we have the double data type, which could be something like 2.23 or this 0.32 or minus 322.22. So you can see the difference here is that now we can have a decimal point. So the double data type it also holds numbers, but there can be numbers with a decimal point, and you cannot store this in an integer variable. This would not work. But if you store it in a double variable, everything's fine. The program knows how to handle this. And if we have a look at the reference again here, you can see if we, let's find the double data type, you can see real types, double or float is also a variable data type, but it's not really used often in programming or in MetaTrader programming, so let's not get into detail here. But the double data type, it will take up 8 bytes now. So if we have a look at the RAM again, the random access memory of your PC, while we are able to store an integer variable in this, like a space, for the double variable, we would need the double amount of space. So this space would be reserved if we declare a double variable somewhere. So you can see this is why we have different data types, because different data types take up different space in the random access memory, and also the bits that are located or that are updated in this specific space are interpreted differently depending on the actual data type. And that's really cool actually, and this is why data types are so important. So besides integer and double, we have some more of these data types that are often used in programming. So we also have the bool data type, which is true or false. So actually it's not an example, because we can only have true or false stored in the Boolean variable or data type. And this is the smallest data type, because it will only hold, wait, can we see it? Yeah, it's only 1 byte large. And I mean, it could actually be 1 bit, because it's just true or false, which is just 1 or 0. But of course, it's 1 byte here, so it all makes sense. So for example, if we declare a byte, a Boolean variable, this is the amount of space that's reserved in your random access memory, because it's just such a small value and it can only be true or false. So let's jump on with the next data type. So for example, we learned about integer variables already, but we also have the data type long, which is pretty similar to a integer data type, because we can also store these values in a long variable. But if we have a look at the reference here, you can see a long is 8 bytes and a int was only 4 bytes. And if you have a look at the minimum and maximum value and compare the values of a integer data type and the long data type, you can see the long data type can be way bigger. And this is pretty much the only difference. It's also a number without a decimal point. This is important, but long values can be way bigger. For example, this would be a possible long value. but this could not be stored in an integer variable because it's just too big. The space in the random access memory, like this is our integer variable. And this value, it's just too big. It doesn't fit. So you need 4 more bytes. And this is why we have different data types. Also, if we would have an even bigger positive number, we could use the unsigned long data type, which is U or U long. And the only difference is in a long data type variable, we could store negative values like this. But in a unsigned long, wait, let me print this here. We can store even bigger values, but they have to be positive because this U means unsigned, so there cannot be a negative or a minus in front of this number. So yeah, so these are some important data types, and we also have the string data type, which is a little bit different because it cannot be a number like this, but it's always a text that is stored inside of a string variable, or which is a string value. And texts in programming in general, and also in MediaTrader programming, they are usually wrapped with these quotation marks. So this is a text, would be a valid string value, but also this, and also the name of your dog, which is Peter, probably, I don't know, could be a string value. But it's important that it's wrapped by these quotation marks. And this is why we always use these quotation marks here for the print function when we wanted to print a text, because this value here is a string value, and this is also a string value. And the reason is not wrapped in quotation marks because it's not a string value. It's actually a variable, which is an integer value. And yeah, this is why you want to use strings for texts. For example, these properties up here, they are all string values. They are all texts. Also this, I mean, it says 1.0, which could be a number, but since it is wrapped by quotation marks, the computer sees this as a text. So for the computer, this is not a number. This is a text because it's wrapped in these quotation marks, and it's this way it is made a string value. Okay, so this is these are the most basic data types, which can also be used for variables then to say the PC how much space we need in the random access memory, right? Because if we would not have data types, the PC would not know like how much space should I reserve for this variable, how should I interpret this variable, because the PC would not know what's going on. But since we have these data types and we can use them for variable declarations, the PC will always know what specific value to expect in such a variable, and like where it's located, because this will point to the location, and then how big it is. So now let's use this variable. We could do something like this, which would store the value 2 inside of this variable. But this is of course not really what we want, because we want to create a handle for our ATR indicator and store it in this variable. So in our onInit function now, in the body of our onInit function, we will say handle ATR, and you can see if we just write the first 3 or 4 letters, it will automatically suggest us this variable, because the program knows that this variable was declared before and it is somewhere, it's existing somewhere. So we can use this handle ATR variable and we can put a value inside of this variable. For example, like this. This would work. It just means whatever value is stored at this position in the random access memory should be overwritten with 2. So now we will have 2 stored at this position in the random access memory. But of course, as I said, we don't want 2. We want the handle for the ATR indicator. And this is why we will use the iATR function or indicator function. So you can see if I write this iATR function, we will already see the signature of this specific function. So you can see the function will return an integer value, and this is where we will have a look at return values for functions, because now it's interesting and important to us. Whenever you call a function and this function has a return value, when the function is processed, Afterwards, it will give you exactly one value back, and this is the return value. We will have a look at this in more detail, but let's have a look at the second part here. I mean, of course, then there's the name of the function, which is IATR, but then we have the parameter list, and this is a little bit more complex now because we have 3 parameters separated by comma. So if we open the parentheses here, we will see the first parameter that is requested is the symbol name. And here we will use the symbol name, which is euro/dollar. So we could go ahead. Oh, and also you can see this is requested as a string value. And that's cool because we know that string values are always wrapped in quotation marks. So we can add something like this, and that's totally fine because it will be euro/dollar as a string value because it's wrapped in quotation marks, right? And then we can go to the second parameter, and as soon as we write this comma, it will automatically suggest a list of all the possible options that we have, because the second parameter is the time frame. Because right now, all of these 3 parameters, they just have one purpose. We want to tell the PC, the MetaTrader, what specific indicator we want to work with. So by calling the IATR function, the program knows we are using the ATR indicator, of course. And by providing euro/dollar, it knows we want to use the euro/dollar chart. And then as a second parameter, we want to use the time frame, which could be H1, which is the 1 hour chart, this one. So now the program knows we want the euro/dollar ATR in the 1 hour chart. And then the last one is the periods. And this is, of course, if we have a look at the inputs for the ATR, this is the ATR period. And these 3 parameters are enough to explain to the computer exactly what specific ATR we want to work with. So after providing all of these 3 values, we can then close the list of these parameters and end the line with a semicolon. And if we compile, no problem, everything's working. So now, what do we do here? Let's have a look at the reference again. You can see the IATR function returns the handle of the average true range indicator. It only has one buffer. Okay, we will get to this later on. Then we will see again an explanation of the parameters. So whenever you have the question about the parameters, you can read about it here. Also, we can see that, for example, for the period, there's a link. So we can click on enum timeframes and we can see all the possible values here. So for example, period H1, this is what we used. It means 1 hour chart. So everything is explained. So you cannot really go wrong here. So you can just read the reference. And then, of course, the value for the averaging period of the indicator. So what is this return value? What does this do? It will return the handle of a specified technical indicator. So what is a handle? Let me explain the concept of a handle in the MetaTrader 5. The handle can be seen as like the MetaTrader 5, it has, or when expert advisors are called, the MetaTrader 5 has a specific point in the memory of your PC reserved for descriptions of indicators. And this handle pretty much just points to this specific point in the memory of your PC that holds the description for this indicator. Which means when we call the IATR function, the computer will go into the random access memory of your PC. And again, the random access memory always looks like this. There are a lot of bits and bytes, right? So this could be a byte, another byte, blah, 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 blah. So you will just have a lot of bits and bytes. And then when we call the IATR function at one specific point in your random access memory, all of these bytes are filled so that it will describe this specific indicator. And I cannot explain to you how exactly the values will look like inside of these bytes. But what I know is that the computer is able to read from these specific bytes, and then it will know how the indicator looks like. Because this is the definition or the characteristics of this indicator stored at this specific position. And the handle, it just points to this position. So the handle is pretty much just the address of this indicator description in the random access memory. So the program will, from now on, whenever we use this handle, and when we use a function, for example, that uses this handle, it will know, okay, this is a indicator handle. Let me search for the position in the memory of the PC, because there I will find the explanation of this indicator, right? So this is so great. And this handle, I can tell you the value. The value will be 10, because the first indicator that you get the handle from in any program has the value 10. But this is not of course, the integer value stored in this variable is 10. But if we tell the MetaTrader that it should be interpreted as a handle, it will know that it will search in the random access memory at the position where the handle for this 10 is stored, and then it will find this specific indicator. So this is the concept of handles in MetaTrader 5. And this is so great, because whenever we want to use this indicator, we don't have to pass around the complete description for this indicator. We can just pass around the handle, and it's just 10. So it's just so easy to pass around this indicator pretty much. And yeah, if we compile this, we can now go ahead and use this handle. Like in the next step, we can already use this to get the values for this ATR indicator. So let's jump to our onInit function, because we want to do this step in every single tick. Here we will call another function, and this function is called copy buffer. And the word buffer, we heard this before. If we read the MQ5 reference here correctly for the IATR, it says it only has one buffer. What does this mean? So indicators in MetaTrader 5, they have buffers. And these buffers hold the values for every single bar. So for example, here, if you have a look at the data window of your MetaTrader 5, if you don't see it, go to View, Data Window. If you have a look at the data window, you will see if the ATR is attached to the chart, you will have this ATR line or column or whatever here. Line is correct. And then, or row. And then you can just choose your crosshair or your mouse and go or hover over the bars. And you can see the value changes for every single bar, because the ATR value is different for every single bar. And this is the buffer, what you can see in the data window for this specific indicator. And this is the only buffer, because the indicator just has one line. So this is, and in the buffer, every single value for every single bar in the chart for this indicator is stored. So what we want to do now in our program is read this buffer, because then we will get the values for this indicator at a specific bar. So for example, we can use this copy buffer function, because it will copy the values from an indicator buffer and it will store it in a variable. So if we open the parentheses with a parameter list here for our copy buffer function, you can see the first parameter is actually an indicator handle. So this is why I explained everything before. We can now just use our handle here and pass it to the function as the first parameter. So this function, it will now know that this handle should be interpreted, or this variable should be interpreted as an indicator handle. So it will find the definition for this indicator. It will know what indicator we're talking about. So if we have a more complex program, and if we have 3 handles, we can just pass the handle for the indicator that we need. And since the handle points to the description of this indicator, the program or the MetaTrader will always know what specific indicator we want to work with, right? And this is super, super cool. And so the second parameter here is the buffer number. And the buffer numbers start at 0. So the first buffer has index 0. And since our ATR, it only has one buffer, of course, it will be 0. Then we have the starting position. So since this buffer of the ATR, as I explained, it will hold a lot of values, like for every single bar. We will have to tell our program what specific values we need. And this is where the starting point is interesting, because starting points start at the very right side, at the last candle in the chart. And this would be index 0. The candle to the left of this one is index 1. the candle to the left of this one is index 2. This is 3, this is 4, this is 5, this is 6, this is 7, and so on and so on. So every single bar has its own index. And if there's a new bar created in the chart, everything changes by one index, because then the new bar is index 0. This would be index 1, this would be 2, 3, 4, and so on and so on. So what we want to do now is we want to get the value for the last bar in the chart. So not the current bar, but the previous bar, which would be index 1 for the starting position. Then we have a count. Like from this point on here, we can define how many bars we want to read from the buffer of this indicator. We could say, for example, 10. Then we would get all the bars up to this one. We could say 5. We would get all the bars up to this one. But we could also say 1 if we just want the value for this specific bar. This is what we want to do. So again, 1 will be provided as a value for the count parameter. And then the last parameter, it looks a little bit weird because it's a double variable pretty much, but it's not the actual variable. It's a reference to a double array. Boom, mind blowing. This sounds super complex, but it's not. Let me explain it to you in a second. So, what are arrays? So until now, we learned that we can have double values, right? This is what we already know. Value. This could hold 23.32. You can see I can compile, no problem, no biggie. This works. But what happens if we want to store multiple double values? We could say we create another double variable, which needs a second name, of course, and we can store something inside of this variable. But this copy buffer function, it can potentially copy 10,000 values from the handle or from the indicator. So it would be a little bit complex to create 10,000 double variables. 10,000. Nobody wants to do this. So there's a concept in programming which is called arrays or fields, which means we just create one array and we make sure that the program knows it's an array by writing these squared brackets after the variable name. And then with a semicolon, we can end the declaration. So this works, no error, no problem. This is now an array. And this array, it can hold one value, for example. And now we can address the values inside of this array. We could say array, which is just the name here, at index 0, because indexing starts at 0 always, even if we only have one value, it's index 0. And we can say inside of this index 0, in this array, we want to place this value. And it works. But what happens if we have 5 values, like this? If we have 5 values, we could say at index 3, I want to store this. At index 2, I want to store this. At index, So if we do it like this, and if we compile, we can now say, for example, print array at index 0. And it will print this. As you can see here, 23.32. What happens if we print index 2? It will print this, because this is at index 2 inside of this array. So how are arrays stored in the random access memory of your PC? So let's have a look at the random access memory again. Let's get some bits and bytes going here. Yeah, somehow like this. I don't know. We have a lot of bytes in the random access memory, and the array, like this variable, it pretty much just points to the very first byte inside of the random access memory where all of these values are stored. And then from this point on, we will just take up the space for example, 1, 2, or 5 double values. So if we declare it like this, this array name, if you want to say so, just points to the first byte inside of the random access memory where all of these values are stored. Because since we know it's 5, there will be stored 5 values of the type double, we know we need 8 bytes for all of these 5 double values. So we need 8 times 5, 40 bytes. So by declaring the array like this, the computer knows, okay, we will need 40 bytes of space. Let me get some 40 bytes of space in the random access memory, and let's point to the first byte. So whenever we use this array, we know what's going on. And yeah, this is pretty much what arrays are and how they are used in programming. And you can declare an array like this when you hard code pretty much the size of this array, but you could also go ahead and say like this, you want a dynamic array. What does this mean? This means that, of course, the PC does not know how big this array might be later on. So this means it will first of all just reserve some space, but then later on, if the size of this array is changed, it might have to relocate the array in the random access memory if it's necessary. But yeah, this is just like not really. This is just background knowledge that you don't need for programming, but what I like to do is explain everything so you actually know what the program is doing. So now, since we have this array, and we could name this ATR, for example, because this is where we want to store the ATR values. And now, since we have this array, we can provide it here as a parameter for the copy buffer function. So if we do it like this and compile, boom, everything's good. Program is happy, we are happy. So, oh, and we don't need this. So what do we do here? We create an array of type double. We use the copy buffer function. And actually this copy buffer function, yeah, you can read it here. It's a good explanation. It will return a value, but it's just the amount of copied data. So, I mean, if we print this, it will be 1 because we want one value, count 1, to be stored inside of the ATR array. So if we print this, it will just print 1. But what happens, yeah, I mean, we don't really need to work with a return type here because it doesn't give us a lot of information. What is more interesting for us is the value inside of this ATR array. So let's print the ATR index 0. Make sure to choose 0 here because we only have one value inside of this array. If we compile this, you can see it prints a ATR value, and this is really cool because it will print the value at the last bar, which will be here in the data window, and you can compare the values. Of course, it's rounded in the data window, but it's exactly the value at the last bar. And this is how to work with indicators. So yeah, so let's get rid of this print statement. And this is the first important step whenever you want to write an indicator expert advisor. First of all, you have to get your handle up and running. This is what we do in the onInit function usually because you don't have to do this on every tick. Oh, here you just have to do this if, for example, the program is activated or if the time frame is changed or something else happens. Then in the onTick function, usually you use the copy buffer function, and you can always use this copy buffer function when you have a handle and want the values from this indicator. And then you just have to provide like the buffer, where you want to start, how many values you want to have, and where you want to store them. So this is how we did this, and this is how you should do it whenever you write the expert advisor with an indicator. So there's one thing that I want to change here in the onInit because we kind of hard-coded the symbol here, which means if we want to run the program in USD Japanese yen, we would have to change this. And there's one easy thing that you can do to make this automatic. So we could go to the ATR function again and read the explanation here for the symbol. And it says the null value means the current chart symbol. So if we go here and instead of Euro US dollar or US dollar Japanese yen, we just print null. We can compile, there's no problem. And now whenever we run the program in any chart, it will automatically take the symbol from this specific chart and initialize this indicator handle for this specific symbol. So that's a good way to automate this step here. Okay, so next up is getting the candle size of the last candle. So this is what we will then want to compare with the ATR value, right? So how do we get the last candle size? There are different ways in MQL5 programming. I will show you the easiest way. So to get the candle size, and we will focus on the focus on the candle body, I would say, we will need to get the open and the close of the last candle. And good thing is in MQL5 programming, we have predefined functions for almost everything. So also for this purpose. And since these values, and before I will explain it to you, you can think about this for a second on your own. What kind of data type do we need to store price data in it? So we know integer, we know double, we know long, whatever. String, of course, doesn't really make sense. But think about it, what data type do we need? And always remember that there is a decimal point in the prices. So, of course, we will need a double data type for this. So what we want to do is we want to create two variables, actually. Let's start with the open here. And we will call this open. So we declare a double variable, which we call open, and we will directly initialize it. So this is the declaration pretty much, where we declare a variable. This is also fine, but we can also initialize it right away. And here we'll use the IOpen function. The IOpen function is a great function that you will use often in your MQL5 programming journey, because this function, if we just have a look at the reference here quickly, it will return the open price of a specific bar. So it makes sense that the return type of this function is of type double, of course, because as we figured out prices are double type values. And the three parameters here are to identify what specific bar we will need. And maybe you remember this string symbol and enum timeframes from the ATR function here. This is a typical concept in MetaTrader 5 programming where you just define the symbol and the time frame. So here we will of course go with null and period H1 again maybe. Then we have the shift value, and this is similar to the starting position or starting value for the copy buffer function. The algorithm or the idea is the same. Like we start at the very right side of the chart. This would be shift value 0, and the next bar is 1, then comes 2, 3, 4, 5, again and again. So indexing of the bars is not always, unfortunately, but most of the time it is like this. So the current or the latest bar is index 0, and then it just adds up the further you look back. So let's go with 1 here, because we get the last value for the ATR here, for the last bar. So we will also get the open and the close for the last bar. And that's it. This will store the open price of the last bar in this double variable. And yeah, it kind of makes sense that we also have the iClose function, which is completely the same, but it will give us the close price of the specified bar. We could also do this for the highs and for the lows. So whenever you need any price of any bar, or also the timestamp of a bar, you can use any of these functions. And that's really great, and it's really handy in a lot of different cases. So if we compile this, and I can quickly print this for you, so you can see that these are indeed the prices of the last bar. If we have a look at the terminal here again, yeah, you can see it prints out. And if we have a look at the data window, like for open and close here, it will, or it should be, the program should print these values, and yes, is indeed what is printed for the last bar. Of course, values are rounded in the data window, but this is what's happening here. Okay, so let's erase the print statement again, and let's move on. So before we start having a look at control structures to figure out if we have a signal, I want to introduce you to input variables. Input variables are always declared on a global scale, which means they're outside of any function. Usually you will declare them at the top. Right now we have one global variable for this program, which is the handle for the ATR. And when it's global, it means that it can be used everywhere in the program. So you can use it here, you can use it here, you can use it here. So you can use global variables in every single function because it is declared on the largest, on the most global scale. There's this concept of scales, or concept of scale or access. I don't know how to pronounce it, but I will explain it to you. So this is on a global scale, so we can use it in any function. There's a difference if we declare the variable inside of a body of a function, for example, because this is now a local variable. This one lives only inside of this scope. I think scope is the right word, but you know what I mean. If you declare something in curly brackets, like this double variable, it's only available in these curly brackets. For example, if I want to change the handle ATR value here, it works. There's no problem. Everything's fine. But if I try to change the open value in some other function, here for example, we get an error because open is an undeclared identifier, which means it's not available or not known in this function. And this is because open is not declared on a global scale or scope. I think scope is the right word. Correct me if I'm wrong. And then we can only use it, since open is a local variable, we can only use it here. But if I want to change it here, there's no problem at all, because here open is known and it's available, but not in other functions, because it's just declared inside of these curly brackets. So this is this mechanism. Okay, so now we learned what global variables are, what local variables are. Now let's have a look at input variables. Input variables are always global variables, and you declare them usually at the very top of your program. And you use them if you have some variable or some value that should be changed or could be changed by the user of the program. So the declaration of an input variable is really, really easy. You just go to the very top of your program, like a global variable, you write something like input. This is the so-called modifier for the input variables. You just add this input in front of the variable declaration, and that's pretty much it. And then we can go ahead and say enum timeframes, for example, and then we go and say time frame, which is the name for this variable, and then we can say, for example, the initial value should be period h1. So what's happening here? This might confuse you a bit. This input is what I explained before. It just says this variable should be an input variable, and how this looks like is what I will show you in a second. Then we have the data type for this variable, and this is enum timeframes, which is confusing to you now. Understandable, because we don't know this yet. But if you go inside of this enum underscore timeframes, everything has to be in capital letters, of course, like this, and press F1, or you go to help and MQL5 reference, you can see this is a enumeration, a so-called enumeration. This is why it starts with enum underscore timeframes. And this is a predefined enumeration. So this is part of the overall MQL5 framework. So we can directly have access to this enumeration. And here you can see all the values that can be stored pretty much in a enum timeframes variable. So this is something that makes working with timeframes easier, because we can now use values or predefined constants or IDs like period h1 or period h4 or m1. So you can see all the timeframes are available now easily, because the program knows that this timeframe variable is of type enum timeframes. Actually, you could also go ahead and say 60, which would work. Oh no, it would not work. Okay, so they changed this somehow. So you can also only use period h1. And this really makes it easy to work with time frames, because then you know in this variable we can only store time frames. But like in the background of this programming stuff, enum timeframes is pretty much just built like an integer, and this variable will hold values, and these values are then transformed to the time frame. But yeah, I don't want to overcomplicate things. This is what enumerations are. And the cool thing is that this time frame variable is now, since this is an input variable, it's available to the user of the program. So if you go to your chart where the ATI breakout program is running and you double click this head, you will see we no longer only have this common tab here, but we will also find inputs. And here, this is so cool. We will find the name for our input variable, and we can change the value. And since it's an enumeration, we have this beautiful drop-down menu, which is super convenient for the user. And if the user now goes ahead and changes this value, it will automatically change the value inside of the input variable in the code. That's so cool, because now we can use this time frame variable whenever we want to use a time frame. For example, here for the ATR function, because you can see the second parameter is of type enum timeframes, and now everything makes sense, right? And we can also use it here, because here we also work with a time frame. So we know that when the user changes something, our whole program will adapt to this change and work with a new time frame from this point on. Also, you might have some inputs that you also want to add. Like, for example, if you're working with indicators, I usually recommend to make all of the indicator properties as input variables. So we can say input int, and now we don't have a enumeration as a data type, but a simple integer variable. We can say something like ATR periods and 14. So this is a normal declaration of an integer variable with an initialization directly. And since the input modifier stands in front of it and it is a global variable, this is an input variable now, and we can use it everywhere in our code. And also the user is able to change this easily. That's the concept of input variables, and I think it's a really beautiful and easy concept. Let's now have a look at the actual signals. And for getting signals, we will need a so-called control structure. So until now, we just added more and more code in the body of functions. The thing is, this is great, but whenever a function is called, all of this code will become executed. So we do not really have any way to make decisions in our program. But when we want to open positions, for example, it is crucial that we do not open positions on every single tick. But first of all, we, for example, want to check some conditions so we can make sure that positions are only opened if we really want this. And for this purpose, we will need control structures. And probably the easiest control structure is a simple if statement. And if statements do exactly what I explained before. They check conditions, or they help you to check conditions. So what we want to do is we want to write if here, which is just like the code word, so the PC knows there is an if statement. And then in round brackets, we will have to write a condition. And this condition is, in most cases, some comparison, some greater, smaller than comparison, like any condition that will result into true or false. So the condition always has to be either true or false. And this will decide how we further process this if statement. So let's build our condition here. Since we have the ATR and the open and the close here, we will go ahead and check. First of all, we want to check if the open is greater than or smaller than the close, because this means the candle is green, right? So this could be a condition. So we have in round brackets, this is our condition, and we usually use logical operators like this, and the most common operators are smaller than, greater than, and then equal. This is equal. You always write two of these equal signs. because only one equal sign would say that you want to assign a value to something, but two equal signs means that you want to compare something. And you can, of course, always say smaller or equal and greater or equal. So these are some of the logical operators that we can use to compare values. And then we also have, if we have multiple conditions, we can combine them using this OR and this AND. So for example, we could say if open is smaller than close, so this is our first condition, which will just check if the value stored in the open variable is smaller than the value stored in the close variable, which means it's a green candle, right? And then we also want to check a second condition, so we can combine two conditions using this AND operator here. We also want to combine if close minus open, and we know that close is the bigger value because this is what we checked before. We want to check if close minus open, put this in brackets because we want to multiply this with a factor. We can say trigger factor, for example, and you might realize we don't know this yet. So we will make this an input variable. So our input variable will be named trigger factor. I would suggest a double variable here so we can choose any value, and we could say 2.5, for example. So this will be our trigger factor. Also note that whenever I declare an input variable, I do this with a capital letter in the beginning, and when I declare normal, like global or local variables, I declare them with a small letter in the beginning, and then from this point on it's camel case either way. So if you have a variable name that consists of two words, you will just write it like this, like every upcoming word after the first one has a capital letter. So this is what camel case is in programming. So now we have this trigger factor, and we can check if the distance from the open to the close multiplied with the trigger factor. Oh no, this was not really correct. We want to check if this is greater than, and then we don't really need the brackets anymore, like the distance of this candle is greater than ATR, the ATR value, which is still stored in our array at index 0, multiplied with the trigger factor. So we want to check if we have a multiple of the ATR in the last candle. And if this is true, then we will add the body of this if statement directly after the closing round bracket of the condition. So what do we have here? We have a condition that checks two different conditions, if you want to say so. So we check if the open price of the last bar is smaller than the close price to figure out it's a green candle. Then we figure out if close minus open, because the close price above the open, if this distance, like the candle size of the body of the candle is greater than the ATR value at this specific candle multiplied with our input factor. And if this is true, this is a buy signal. And that's it. It's really this easy. And maybe you realize that we use these curly brackets. Until now, we only knew curly brackets for the body of functions, like here. In this case, we also use curly brackets because if statements also have a body. So whenever you have a body, it's usually wrapped with these curly brackets. And this body of the if statement is only executed if this condition is true. And this is why if statements are control structures, because they control the flow of your code. You can have conditions checked, and only if the condition is true, we will enter the body here. So for example, if you want to open a position, you usually check some condition before, so you don't open positions with every single tick. And yeah, make sure to use these logical operators for the conditions of your if statement. So, for example, you can combine multiple conditions using this AND, and you could say, if I only want one of these conditions to be true in order to enter the body of the if statement, I will use this OR operator. But in this case, of course, this doesn't really make sense because we want both conditions to be true. So let me erase this quickly, and if we compile this, and add a print statement here by signal, something like this. And now we can actually search for signals already. So let's make a simple test. Go to your MetaTrader 5, then go to View Strategy Tester, and you can also press Ctrl and R instead. And let me delete or close the toolbox here. And then you go to Overview in the Strategy Tester, select Visualize. Then in the Experts drop-down menu, you choose the expert name that you just wrote. ATR Breakout YouTube, is it for me? Then you can choose a symbol that you want to test, a time frame that you want to test. I will go with H1 because this is my input also. And then you can test a time period. I will just go with the current year here. Like 2023, and yeah, it's just for testing to see if the program works. And the rest is not really important for us. If you want to test like later on, you should use everything based on Realtix because it's the most accurate method. But yeah, for just testing the signals now, these things do not really matter. Just make sure that this visual mode checkbox here is ticked. Then you will also find the inputs here in the tester. So you could change this here, but we will go with the default settings for now to just check if the program is running. When you then click Start in the lower right corner of the tester, it will open a separate window with the visual mode of this strategy test. And you can see it will now take historical data in the selected period, for me starting in the beginning of 2023, and it will run the selected program, in this case the ATR program, in the tester. And we can also see the ATR and everything, and you will see the H1 candles are now displayed here in the chart. And we also have a journal. So if we speed up the process here, we will see if there's a really big candle like this one, and there is a signal, we should see it printed. But since this is a short candle and we didn't add the short signals yet, we don't get a print message. But here, okay, we have some signals. This is great. So the last signal was 1859. So in this bar here, we had a buy signal because this bar had a size of 700 points and the ATR was just 270 points or 260. So 260 times 2.5, which is our input for the trigger factor, should be below 700 whatever. So this would be an input, and this would actually be a good input or entry because the market proceeds to go into this direction. Okay, so let's add the short signals here. We can just copy this complete block, like select it, copy, and then paste it here. When you copy things, make sure to be really careful because often you forget to change something and then it kind of messes up the code. So it's easier or safer to just write it again because this will prevent errors often. But here we want to check if the open price of the last bar is above the close price, which means it's a red bar. And then we check the open minus close, of course, because open is now the bigger value. If this is greater than ATR multiplied with the trigger factor, and in this case, it is a sell signal. So if we compile again, we should see that if we run the same test again, just go back to the strategy tester, start it again, and now we should see that also the sell signals are printed in the journal, right? So let's wait until this test is loaded, and yeah, this was the big red bar that I showed to you before, and now this will also give us the sell signal. Isn't this great? So this is what control structures are for. Usually you have if statements and loops. We will have a look at loops later on. You always use loops if you want to process something multiple times. And we will use this when we add a trailing stop later on. But first of all, let me show you one more thing for the if statements. If you have multiple if statements following each other and only one of these if statements can be true because the conditions exclude each other, you can also concatenate multiple if statements like this. So you can write an else if, and this will make the only difference that the program checks this if statement first because it comes first in the code. And if this is true, it will execute the body of this if statement and it will not look at this part because there's an else if. But if this condition is false, it will still look at this part because the first condition was false. And this can, in some occasions, be useful to speed up your program a little bit. But yeah, nowadays with the speed of modern computers, it doesn't really make a lot of difference, I think. But it still can add some, it can make your code look cleaner because this is now a block and you really know that only one condition can be true. Also, please realize that whenever I put my curly brackets, usually I like to put the opening curly bracket directly after the closing of the round bracket, and then my closing curly bracket like aligned with the if statement or with the controlled structure, like I do it here. And then everything inside of the body should be moved to the right using the tabulator button on your keyboard. This will make everything really clean and tidy. So you know everything that's moved to the right here. And we could have more code like this, and even more code and more. And you can see since this block is moved completely to the right, we know that everything here is inside of the body of this if statement. This adds so much more understanding for you when you look at your code later on, and makes it look much cleaner. Also, personally, I like to do it for the functions also. So normally I write my opening brackets for functions and closing brackets like this. And yeah, you can decide if you also want to do it like this. It's just what I do because it kind of saves some lines in the code, makes it a little bit shorter, but it's personal preference. So there's no wrong, no right. You could also go ahead and do it like this. This makes absolutely no sense because it's super ugly, but it still works. And the program doesn't really care. You can have as many spaces and breaks in between, but this is personally my preferred style. Okay, so since we have the signals now, as the next thing we want to do is open positions. So to open positions, you will use the order send function, or you could use the order send function. But if we have a look at the order send function in the reference, there's a really big entry. You will use these structures here that are super complex and that you would have to fill. And I don't want to get you through this whole struggle. And there's a really easy and quick way to open positions. We can use another file that is available in your MediaTrader 5 terminal. So you shouldn't worry about this. And we can include this file at the top of our program. Or this is where you usually want to do this. So after or below the properties, write this hashtag and then write include, which means we want to include another file. And then write in spiky brackets, which is just a smaller sign and then a greater sign in the end. You write trade/trade.mqh and end it with a greater sign or another spiky bracket like this. If we compile this, you can see there's something going on in the toolbox down here. Previously, we only saw ATR Breakout YouTube MQ5 program was compiled, but now a lot of other files are compiled. And this is because we included another separate file. And we can find this file in the navigator of our MetaEditor, sorry. So if you go to the navigator, you will find a include folder. If you open it, you will find a trade folder, which is the first part of our path here. And in this trade folder, you will find a trade.mqh file, which is this. So this is just the path to a file that we want to include. And if we open this file, we can see it's a really big file. It's a little bit confusing right in the beginning if we just started programming. But the good thing is we don't have to understand everything here. Not yet. You don't have to understand this. Let me explain this easily for you. So this is a so-called class. A class is pretty much just a structure, a data structure that holds variables and functions. And we can use this class. Let me close this. This might be confusing. We will use this class to have access to all of these predefined functions and variables. So what we can do by including this trade.mqh file and the ctrade class, we can have access to a lot of different functions that we do not have to write on our own. So for example, what the class does, this specific ctrade class does, it works with complex functions like this order send function. And it will break down everything for us, so we will have access to all of these functions, but in a much easier way. So let me show you how it's done. Since we included this file now, we now have access to this ctrade class. So we will declare another global variable and we will name it, it is of type ctrade. And this is exactly the data type of this class, or the name of the class, not the data type really. And then we can declare a variable of this type, which we call trade, for example. I mean, you can choose any name, something like this, whatever you like. It's just the name. And then we can end the line with a semicolon. And if we compile, you can see no error, everything's good. What we did here is essentially we declared a variable. But in this case, it's not a normal variable with a simple data type, but it's a variable which is a so-called object variable. Sounds a little bit confusing, but in fact, it's just a variable of type ctrade, which means that this trade variable can now be used, or trade object, if you hear this term somewhere, it can now be used to have access to all or most of the functions in this ctrade class. And this is so cool. I mean, you might be confused now, but let me show you how to use this ctrade class for easy position opening. And that's when you will understand why we did this. So whenever you open positions or you want to open positions in your program, just include the file, create a variable like this, and then you can use this variable to open positions. So go into your code where you want to open positions and write trade, which is the name of your variable here, and then a point operator directly following the name of the variable. And then you can see we already get a suggestion of a lot of different functions that we can now use completely for free. We didn't have to write any of these functions. So we can say buy, for example, because we want to buy here. And now, from now on, everything's like always. It's just a normal function call. We can open the parameters of this function and you can see the list that you can provide. And now we can say how much lots, for example, we want to open with this position. And here again, I recommend to make this an input variable. I usually put this at the top, and it's a double variable, of course, because it can be a value with a decimal point. So this is our lots variable now, global variable, input variable, nothing special, and we can use it here to open this specific amount of lots for buy position. So we have some more function parameters here. But you can see these function parameters, they have a so-called default value. You can see this because after the function, the parameter name, which is here in this case symbol, there is an equal sign and there is null default assigned by default. Also for the next parameter price, there's 0 by default assigned. Then SL is also 0, TP is also 0, and comment is null. So you can see all of these parameters have default values. So we can stop the parameter list after lots. And this means that the function will just use the default values. It will not work if we don't provide the lots, because lots, as you can see here, it doesn't have a default value. So this is what we will have to provide. But if we do it like this, we can open by positions. And let's just copy this quickly to also open cell positions with a lot size if there's a cell signal. So let's see what's going on if we compile this now and make another test. Go back to your tester in the MetaTrader, click on start and see what the program is doing now. And this is so cool because by just including this ctrade class or this file and using the ctrade class, we can now open positions so quickly. So you can see here, there's the cell signal and directly we will open a position. Isn't this beautiful? And actually we do not only open one position, but we will open a position with every single tick. And this is not really cool, but it's what our program currently looks like, because you can see all of this stuff is currently located in the onTick function. So we will do this with every single tick. And this is something which you don't want. This is really a bad idea because it can mess up your whole account. So what you want to do, you don't have to be afraid of this. There's an easy fix for this, and I will show it to you now. We will create another global variable for this. Let's call it bars total. And this bars total will be used now later on. So first of all, let's initialize this in the onInit function. We will use the return value of the ibars function, which has 2 parameters, and we know these 2 parameters. So let's just use null again and time frame. So this will give us the total amount of bars. It has a return value of type integer. It will return the total amount of bars in a specific chart. So let's have a look at our chart. This chart, it might have, 100,000 bars maybe. So this is the value that will be stored in this bars total variable. And now in the onTick function, at the very beginning, we want to calculate the ibars function again and get the amount of bars again. Everything's the same pretty much, but we store it in the bars variable. And this one is a local variable in the onTick function because we only need it here. So now we have the bars variable and the bars total variable. These 2 variables are completely different. Bars total is global, bars is local. And what we want to do is we want to compare these 2 values. And if we compare something, we need a control structure, right? And this is where our if statement comes back. So we will write if bars total is unequal. Oh, and this is another operator that you can use. So this would be equal, and exclamation mark and 1 equal sign is unequal. So it will compare 2 values, and if these 2 values are different, then the condition is true, right? So we want to check if these 2 values are not the same, because it means that there's a new bar, because this bars variable is calculated on every single tick, while this bars total variable is not calculated on every single tick. So this bars total variable will keep its value as long as it is changed manually by us. So we will check if bars total is unequal bars, and if this is true, we will update the value in the bars total variable, which means that this only happens once at the beginning of a new bar, because then the bars value will be higher than the bars total value. And this is when we want to enter the body of this if statement. So let's think about what we want to add inside of the body of our if statement. Of course, we want to add all of this code here because we want to calculate the ATR only once. Only once we want to calculate the open and the close of the last bar, because these values won't change anyways in the current bar, because the last bar is always the same, right? So we can select everything here and then just press the tabulator button on your keyboard, and it will move everything to the right by 3 spaces. And then after this block here, make sure to go to the next line, and then at this position close the body of this if statement. And you can see if you move your cursor after the opening bracket for the body of this if statement here, it will also highlight the closing bracket for this if statement. And you can see now all of this alignment stuff, like moving stuff to the right and everything, makes sense, because you know everything that is aligned like this here, it's in the body of this if statement, and everything that is even further to the right is in the body of this if statement. So you can build multiple if statements around each other, and only like the scope is always getting smaller and smaller. So everything that is inside of this if statement is only processed if this is true, and what's inside here is only processed if this is true, and what's inside here is only processed if this is true. So you can see the scope is always getting smaller and smaller. So yeah, it's more likely to reach this piece of code than this, and it's still more likely to reach this piece of code than this or this. So this is why you use control structures to structure your code. And if we compile the program again, you can see no errors, everything should be fine here. Just make sure to not like forget to close brackets or open and close brackets, and align everything, and make sure you add the semicolons if necessary, and yeah. But then if you compile and do the same test again, Same data, same period, same everything, but now we made sure that the code is only processed not with every single tick, but only once per bar. And this will be really important because now if there's the sell signal, we only see one position, and this is exactly what we wanted, right? So you can see in the journal it now only prints once that there's a sell signal, and then we will open exactly one position. And you can see here also, this is done by the ctrade class that we included. And this is why this is so convenient to use this class. So let's speed this up a little bit. Let's wait for some more signals. There's some buy signals, and then we will see more signals probably. Yeah, so you can see there are some signals going on. So our program is working just fine. So next, we should now have a look at how to make the position opening a little bit more useful. So we will work maybe with the TP, with the SL, and we will move everything to a separate function to make it even cleaner in the source code. But first, let's have a look at adding these trade parameters like the buy, the TP, the stop loss, and everything. So let's first of all have a look at the list again that is requested for these buy and sell functions. So you can see the next parameter is what we can easily provide. It's the symbol, and here we will just go with null again because we just want to use just the chart symbol usually. Then the next parameter is the price, and this is our entry or open price. So prices, again, always double values, makes sense, right? So we will create a variable which we call entry. Well, this is what I usually call it, and we will use the return value of symbol info double, and then you can see here in the signature it returns a double value, and the first one is the symbol name again, and I think we can use null here, and the second one is a identifier, and you can see as soon as we get to the second parameter we see a list of all the variable identifiers already. So what I want to use here is symbol ask. So let's close the parameter list for this function. Let's end the line with a semicolon, and let's have a look at this function. So symbol info double. Okay, it says we cannot use null. Let's still try this. But what this function does is it will return a property of a specified symbol. So you can see the second one is the property ID. And if we have a look at this link here, you can see all of the IDs. So in this case, for example, we can get the bid and the ask price easily by using symbol underscore ask and symbol underscore bid. This is what we did here. We used the ask price. So let's now use this entry here as a parameter for our buy function, right? So yeah. Also, what I would recommend is that when you work with values like this that should be used for opening, modifying positions, it's always a good idea to round these values so there are no unexpected, unwanted digits after the decimal point. And the easiest way to do so is using the normalize double function, because you can see this will round a floating point number to a specified accuracy. And you can see there are two parameters requested, the double value that you want to round and the amount of digits after the decimal point that you round this value to, and then the rounded value is returned in the return value. So what we do here, we just use the entry, round it to the amount of digits for this symbol. So it would be 5 in this case for euro US dollar. But this might change if we use it for USD Japanese yen, for example, because USD Japanese yen only has 3. So there's a quick fix for this in programming. In the MetaTrader 5 programming, you can use underscore digits here. So what does this do? Let's have a look at the reference. An underscore digits is a variable, a system variable that is predefined by the MetaTrader and will always hold the accuracy of the chart symbol. So it's the amount of digits after the decimal point for whatever chart the program is running in. So we can easily use this. And in this case, for example, for euro US dollar, it would hold the value 5. For USD Japanese yen, it would be 3. For some ETFs or CFDs like the Dow Jones, it would be 2 usually. So you can see it adjusts to the chart symbol. So if we compile this and run it again, it should not really change something, but I want to see if we can use the entry like this, or if we can use null here, because this was not printed in the reference. So I will have to check this so we don't get any problems here. So let's get until the first buy signal. So we will see that this is printed. And yeah, looks like we can use null and we get the correct values, I think. Yeah, this is fine. Also, if we were not able to use null here, you can always use underscore symbol, which is a little bit similar to underscore digits. Since underscore digits gives the amount of digits after the decimal point for the current chart symbol, the underscore symbol will give us the name of the current chart symbol. And this is, of course, a string. Yeah, you can see like here, the symbol contains the symbol name of the current chart symbol. This is string system variable. Okay, so now we calculated the entry, and we can now use this entry variable to calculate the TP, for example. So let's create another variable, and we will calculate the TP by using the entry and adding, let's say, 100 points. And here we will see another system variable. So you can see this will hold the point value for the current chart symbol. And the point value is always the smallest possible price change in a symbol. Like for example, for euro US dollar, it would be 0.00001. This would be 1 point for euro US dollar, like this. And this would be 1 point for USD Japanese yen, because it only has 3 digits after the decimal point. And if we multiply this value with 100, it's equal this. So if we add this to the open price of our position, we get the TP price, which is again a price. So when you provide the TP here for the buy and sell function in the SL, it's not the distance that is requested, but it's really a fixed price where the TP and SL should be located. So we can calculate the TP like this. But of course, hard coding 100 is really not a good programming habit, I would say. So it's really much better to say we want to have TP points here as an input variable. So let's go to the top, input int TP points, and here we can see 100, 200, whatever. And also let me get sure that we also see the SL points as a input variable, maybe 100, 200, 500. You can use whatever you want, right? So let's use 200 for both of these for now. So we will use the SL points now to calculate the SL. So double SL is equal to entry minus SL points multiplied with points. So process is really similar. Also, what I want to do is round these values using the normalized double function. And of course, we round the SL and the TP. So now, since we calculated all of these values, we can now use the variables SL and TP here for our buy and sell function. Like this. If we compile this and run the program, we should now see that all of our buy positions have a TP and a SL. So this will make sure that these functions are closed at some point and they don't just stay alive for as long as possible. So let's wait. Sell positions do not have TP and SL. We will add this code in a second. But buy positions, there we go, have a TP and a SL, so they will be closed at some point. Yeah, I mean, the TP and SL is a little bit too close, as we can see here, but you can see also in the history, there's always a TP and a SL, and yeah, let's maybe make the values a little bit bigger. Also, we can increase the default values here, I think, because they were like just too small. So if we go with some bigger values and go use these values in the tester, let's just test this again, and then we can see like actually where these values are placed, like the levels are placed for our buy trades. So let's wait for the first buy trade. There it is, and beautiful trade. Let's have a look at this. This is a buy trade, and we can see it was opened here. So from this position on, we have around, not around, but exactly like 1,000 points from the position opening ask price and 500 points for the stop loss. And these levels are also visible in the trade overview here. Like this. So you can see TP and SL are assigned for this trade, and now we can wait until the TP in this case luckily was hit. So let's add this code for the sell positions, so they also have the chance to be profitable or negative if they hit the stop loss. Like the easiest way would be to just copy everything, but again, I would suggest that you just write it again so you will have a better routine. So let's go with a double entry and make sure to, we have to declare this variable again, because this double entry and double TP and double SL variable, they are declared in the scope of this if statement, in the body of this if statement. So all of these variables, they're only alive in the body of this if statement. And once the body is processed and left, these variables will also be erased from the random access memory of your PC directly. This is why, on lower scope or smaller scope, the variables are deleted earlier again. And on the global scope, for example, they will stay alive for the whole runtime of your program. That's also a big difference with where you define your variables. So here for example, if I want to change entry here now, it doesn't work because it's not known here yet. It's only available here in the scope. So let's go here and declare it again for this reason. So symbol info double. In this case, we will use symbol bit because sell positions are always opened at the bid price. And then let's round this. This is completely the same because the amount of digits is the same for buy and sell positions, of course. Then we have the TP. Here the calculation is a little bit different because we have to subtract the TP points from the entry. But the rest, again, completely the same. We will round this, make sure that there are no unwanted digits after the decimal point. And then we will go and do the stuff for the SL. In this case, it has to be SL points above, so plus above the entry. And then we will just go and round this value like this. And then we can just use these variables here and add them for the buy and for the sell positions. And there's one last parameter for the buy and sell function, which is the comment, and it is a string value, so we can add a string comment here. We could write something like ATR breakout as a comment. You can also make this a input variable. This is what I like to do. I would open or create a variable which I name commentary often. And we will just add this as a last parameter for the buy and sell function. And then, of course, we will have to declare this variable here as a string input variable, which could have the default value ATR breakout, like this. If we compile this and run the program again, we should now see that, we get this input variable here, and all of our buy and sell positions, they should now have TPs, stop losses, and the comment. So let's fast forward until we see the first position. So you can see sell position now also has a TP, and we can of course check the TP and stop loss level if they are correct. But they are correct. 100 points TP, 500 points stop loss, and there's also the comment available now, which is ATR breakout. So you can see this is working just as we wanted it to work. But now, what is happening to our onTick function? You can see the onTick function is becoming a little bit big and a little bit messy, if you want to say so. It's not like you can look at it and you will directly understand what's going on, because there are just so many lines right now. And whenever you have something like opening a position, you can move this to a separate function. And there are different reasons why you use functions. For example, if you have a task that is a isolated task that is only there to do one thing, like opening a buy or sell position. And this task is kind of self-explanatory. or self-explaining. In this case, you can move the code for this specific task to a separate function. Also, there's a second reason why you would use functions in your source code. If you have some piece of code that you use multiple times at different positions in your code, you will also want to move this to a separate function. So let's now create our first function together. So when we write new functions, we do this outside of any other function. So right now we always worked in some of these event handling functions that are automatically called by the system. But we still have the chance to create our own functions that we can then call whenever we feel the need to. So let's go at the very bottom of our program. Let's give it some space and then let's create our own function. And we learned about the function signature already. So this is what we need to define first for our own function. So we need a return type, can be int, can be double, can be string, can be void, which is nothing. So let's go with void first. Now we can choose a function name. And we will go with, or I usually go with execute by as a function name for the function that opens a by position. And then a function always needs the parameter list. And this parameter list can be empty like this, but we need to add these two round brackets. So if we compile it like this, it will not really work because there's the unexpected end of program. Because a function definition, or when we define a function, we also have to add the body. Like this. Body again in curly brackets as usual. So this is our function now. So what do we see here? We have a function which is called execute by. It has a return type void and it has no parameters. And we could add a parameter here, for example. We could say the parameter should be int. Or wait, let's have a look at what happens when we call this function. And I want to do some examples here so you really understand what's going on. So let's call the function in the onInit function. So you always have to call your custom functions in some event handling functions because otherwise they will never become executed. Because these event handling functions, they are automatically called by the MetaTrader if there's a specific event. But there's no specific event in the MetaTrader for the execute by function, right? So we will have to call this explicitly to be processed. So in our onInit function, for example, we could say execute by. Just call the function by its name and then add the parameter list even if it's empty. You always have to add this. And then end the line with the semicolon. This will call the execute by function. So let's compile this and see what's happening. So let's go back to our toolbox in our MetaTrader 5 by pressing Ctrl T or clicking View Toolbox. And here we can see in the expert journal, this is the onInit function is printed, but yeah, I don't see anything about our particular execute by function. This is because the function has an empty body. But what happens if we add something here? Like this is the execute by function, like this. If we compile this again, we will now see this is the execute by function because it is called in the onInit function. So the onInit function, when the onInit function is called, it will do this, and then it will call the execute by function because it's part of the onInit function. And in the execute by function, we see this is the execute by function. Also, we could have a parameter here. For example, int number, like any number, it doesn't really matter, or double another number. And we could print these numbers. We could say print the number is, and then we go and print the number, and we can say print the second number is another number. And then we could also do some operations here, like mathematical stuff, like the sum is number plus another number. So you can work with these variables inside of the body of the execute by like they are normal variables. If we compile this, we get an error though. because now it says execute by function has a wrong parameter count. If we double click this arrow, it should move us up here to this line where the execute by function is called. Because now when we open the parameter list here, the parentheses, we see that two parameters are requested. A number is an integer, for example 5, and another number can be a double number, so 2.2 for example. So if we compile again, error is gone, and now the output is really different. Because it says this is the execute by function, the number is 5, the second number is 2.2, and the sum is 7.2. So this is how functions can be used. And I could say I want to do this multiple times, also with 10 and 11.4, or also with 1 and 2, or also with 10 and 100. So you can see this is the power of custom functions. I can also call this in the on dinit function with some stuff. And so you can see if I compile this, like in the on tick and in the on init, all of these execute stuff things are called. Just play around with this and you will understand how it works. And this is the power of having custom functions, because we don't have to add this code, like the whole code here, multiple times in our on init and on dinit function. We can just call the function multiple times. So let's get rid of the code in the on init and on dinit, and let's add the actual code for our function. Or maybe we can also, let's say I will tell you how to work with the return value here. We could say we want a double return value, just exchange void with double. And then we can say we want to return the sum. So if I compile it like this, it will not work, because now since we defined a return value, we always have to provide a return value. So at the end of your function, you will write return, and then you can say whatever you want to return. For example, I want to return number multiplied with another number, like this. If I compile this, we will see if I call the execute by, we still need two numbers. And now it has a return value. So I can store this return value in a variable and I can print it, like return value is, and then I print the value, right? So if I compile this, it will give me the information that the return value is 44. Isn't this cool? I think it is. Oh, and yeah, this is something that I kind of messed up. The return value is 44 because the program now assumes that this is a integer value. So you can typecast this to a double value by saying to the computer that this is indeed or should be treated as a double value. This is so-called typecasting. But I won't get into detail. But, oh, wait a second. 2.2. Oh, we don't, oh, sorry. Forget everything I said. We don't need this. It's all fine. Since we have one double value already. Yeah, you can see like the calculation is working. Sometimes when you do mathematical operations, you will see some unexpected digit after the decimal point, like this, like the 6 at the very end. It's just like because computers are designed like this, and sometimes they will create some number that doesn't really make sense to you, but it is there. And this is why also we work with this normalized double if we want accurate price data. But yeah, let me delete this again in the onInit. And this was just to explain how the return type works. But in this case, I think we don't even need this. And also, we do not need any parameters. I just wanted to make sure that you understand what you can do with functions. But here, all I want to do in this execute by function is I want to take the code that is responsible for opening a by position. I want to cut it from here. I want to paste it in the execute by function. Wait. I want to paste it here. And then, of course, I want to move it a little bit to the left. You can do this by pressing tabulator, but holding your shift button on the keyboard. And this will then be the execute by function. If we compile this, everything's working just fine. And now instead of having all of this up here, we can just say execute by. And this will make the whole on tick function so much shorter, so much cleaner. And I will do the same thing, cutting this for the cell stuff. And I will say void execute cell with no parameters. I will add the block here. I will move it a little bit to the left because it's not in such a small scope. It's just inside of the body of this function. And if we compile this and add the execute cell here where we want to execute the cell signal, you can see the onTick function is now again really small, clean, and by reading the function name, we already know what the function is doing. So it's really explaining itself just by the name. So we can just be confident and sure that whenever we call this function, it will just process this code and open it by position. So this is when you can use functions. And to show you that everything is still working just like before, I will do another test. So let's go back to the tester. And yeah, let's just run the same test. And all of this, what we just did is, first of all, I wanted to explain functions to you. But second of all, I wanted to make the onTick function clean and easy to understand. And this should always be the aim for any expert advisor, to just have a good and clean source code. So you can see the program is still working just like before, but now we are using these functions to make everything a little bit more, a little bit cleaner and tidy inside of the onTick function. So now, as a last big function, we want to add the trailing stop loss, right? So if we have positions and they are going into our favor, we want to trail the stop loss. So what we will learn is how to modify positions, how to calculate stop losses and everything. And to really do this, we first of all have to understand how positions are managed in the MetaTrader 5. So let me run another test for this demonstration here. Let me get this test sped up a little bit so we can see some of these positions. So you can see at some point, sometimes we will have one position open or multiple positions open at the same time. And actually I want to see a moment where we have multiple positions active at the same time. And maybe I should, let me just increase the TP and SL points for this purpose. So it's easier to catch this moment. So maybe let's go with 2000 for TP and SL points. And since these are input variables, we can just change them quickly. No big deal. So now, since we as a user changed the inputs, we will see a larger distance for TP and SL. So here we will now see multiple positions are open at the same time. So whenever we have multiple positions open at the same time, they are in our toolbox in the trade window. And these positions, they all have a specific index. For example, the first position would be index 0, this would be index 1, and this would be index 2. If we would have more positions, we would have index 3, 4, 5, 6, 7. Like, it's always like this. First position has index 0, then 1, then 2. And this always works. Like, if we see only one position, we only have index 0. If we have 2, we have index 0 and index 1 again. And as always, like the top position is index 0, followed by 1, by 2, 3, 4, 5, 6, 7, 8. So why am I explaining this? We will need this indexing now when we use our first loop in this program. So let's go back to our program and remember this indexing stuff. So we will go to the onTick function, and now we go outside of this if statement because we want the trailing stop to be processed with every single tick. And what we want to do now is we want to use our first loop. A loop is used if you want to do something multiple times. So here we want to process the trailing stop for every potential position that might be open at the time. Could be only one position, could be 2, could be 3, could be 10. So we will use for, which is like the code word for the for loop, similar to if. And for loops, by the way, are control structures. So they control the flow of your program. So we will write for, and then we need round brackets again to initialize our for loop. And here we have 3 different sections. The first section is like the section that is, or the code that is processed once when the for loop is started, so to say. Most of the time, you will see a definition of a variable. Usually, it is an integer variable called I, which will have a value like 0, for example. And then, like for now, just copy what I'm writing here. Then you write a semicolon, and then you go on to the second part of this for loop initialization process. Here we have the main condition of this for loop. So the for loop, it will check a specific condition multiple times. The condition is just what we used before. It can be set up using like logical operators and stuff and values and variables. So what we want to do is we check if this variable I, if it is smaller than the total amount of positions in this account. And the total amount of positions is what we can get using the positions total function. It's a system function, predefined, we don't have to write it, but it will give us the total amount of open positions as an integer value. And as I explained this before, it can be 1, can be 2, can be 3. So as long as I is smaller than the total amount of positions, we are good to go. Then we have a third section here, which is the code that is processed after every loop run. And here we write I is equal I plus 1, because we want to increase I by 1. Then we end this set of conditions and operations by closing the round bracket here with another round bracket, and then we add the body of this for loop. So if we compile, first of all, we should not get any errors. So now let's have a look at what's going on here. If we just print I and say maybe this is the loop and I is, and then we print the value I. So let's just see what's going on for now. So let's run another test, just like we did before. And let's see what is going on now since we added this to the onTick function. So in the journal, we should see the print statement at some point, right? But we don't see anything. Okay, let's speed up. Let's see what happens if we see the first position. There is the first position. So you can see now we start to enter the body of this for loop and we print this is the loop and I is 0. Why is this happening? Let's have a look at this again. Like this line here is processed with every tick. But not this line, because this is in the body of the for loop. So what happens when the program reaches this line? First of all, the program realizes, okay, this is a for loop. I have to be ready to check out these 3 things here, these 3 statements, or whatever you want to call it. First of all, I will have a look at this precondition, or the first statement. So I will do whatever is written here. So first of all, the program will create a new variable, which is called I, and it will have the first value 0. Then as a second step, the computer will have a look at the second section here. So it will check if I is smaller than positions total. And since at this point in our test, positions total is 1, since we have 1 position, right? This condition is completely true. Because 0, which is stored in I, is smaller than 1, which is the return value of positions total. So since this is true, the program will not go here next, but instead, after checking the main condition, the program or the computer will go here and execute everything that is inside of the body of the for loop. And here we will therefore print this print statement and will say, or we'll print the value I. And this is what's going on here in the test right now. And then after doing this, the program will go here and will process whatever is written here. And in this case, we will increase I by 1. And now I is 1. And then it will check the main condition again. So we don't do this again. This is what we only do once when we initialize the for loop. But we will check this condition every time before we process the body of the loop. So then we will check I smaller positions total again. But since we increased I by 1, I is now 1 and 1 is not smaller than 1. So at this point, the main condition is false, and then we directly leave the for loop and go on with the rest of the code. So this is how for loops are processed. So let's go on in our test. What happens if I just speed up the test and go to the point where we see another position open? So what's happening now? You can assume it already probably. So you can see now we have 2 or actually 3 positions. So positions total will now give us the value 3. And in the journal, we will see this is the loop and I is 0. And then again, this is the loop and I is 1. And this is the loop and I is 2. Because now the process is the same. Like we go and enter the loop. We will initialize I with 0. We will check if I is smaller than positions total. But this time, positions total is 3 and not 1. So after processing the body for the first time and print this is the loop and I is 0, we will then increase I by 1. Now I is 1. And then we check if 1 is smaller than 3, which is still true. So now, since the positions total kind of changed, the condition is true more often than it was before. So we will print this again with I1 being 1, and then we will increase it again. So I is 2, which is still a true condition. Then we will print I with a value of 2. Then we will increase I again. Now it is 3, and now it is no longer smaller than positions total, so we will end the loop. So this is why we use this for loop concept to loop through every single position. And since these positions also have the index 0 all the way to 3, as I tried to explain before, so this is 0, this is 1, this is 3, we can now use this position index to get the ticket of the position. So we can get the ticket using the position get ticket function, which is a predefined function, and you can see the only requested parameter is the position index. Now everything makes sense because we can just provide I as the position index, and this will give us the position ticket. You can see it in the reference. This will give us the ticket of a position with a specified index, and the return value is unsigned long. This is what we learned at the very beginning when we talked about data types. Long variables are pretty much like integer variables, but they can be way bigger. An unsigned long just means it can only be positive. So we have to create an unsigned long variable, which is called position ticket, and then we will initialize it or store the value, the return value of this position get ticket function inside of this variable. And yeah, now we have access to the position ticket, and also there's one more thing, because this will automatically select the position. What does this mean? It means we have access to the position get double, position get integer, and position get string function, which we can use now. Like, let me give you an example. We can say print position ticket, and then we can say we also want to print the position open price. So we can say position price open is equal to position get double, and we can only do this because we selected a position before using this function. Because the position get double function will always get you a information from the currently selected position. And when we go here into the parameters of the position get double function, you can already see what parameters are available here. For example, the open price of the position. Like if you have a look at this in the reference, you can of course also have a look at all of these things here and the explanation. So we can say position price open is the open price for this position. So now, oh wait, I messed up something, forgot to close this here, and I forgot to add the comma. But if I do it like this, compile, and if we run the same test again, this is now really cool, because we will see that we will print all of the position tickets and all of the open prices for these positions now. So let's get the first position. So you can see, oh, we have 3 positions. Oh, wait. Oh yeah, the ticket number is 2 of this position, and the open price is 1.0551 0.14, and this is indeed what is printed here. And if we see multiple positions now, we can see all of these positions are printed, so all of the position ticket numbers are printed, and also the open prices are printed. So this is really cool, I think. So we will now use this concept, of course, not to only print the open price, but we want to use this to just process the trailing stop. So for this purpose, let's first of all get the stop loss of the open position. Position get double, position stop loss. And it's always the same concept. If you want to get a double information from a currently selected position, you can just use the position get double function for this. So now what we want to do next is we want to check if, and now we do something else. Now we do if position get integer, because now we want an integer value, and we say position get, position type, if this is equal to position type by, then we want to do something. So this is again an if statement, so we are checking a condition, and only if this condition is true, we want to enter the body. And of course, we will also check if it is not a buy position, then it can be a sell position. This is what we want to do here. Position type sell. So what did I just do? I called the position get integer function. It's really similar to the position get double function, but it will return an integer value. So if we have a look at this enumeration here, we can have a look at all the possible options. And you can see one of these options is position type. This is the one that we used. And if you have a look at the description, it says it's the position type. And if you have a look at the type, it is enum position type. If we click on this link, we will see all of the available position types. And there are only two. It can be either a buy position or a sell position. And this is exactly what I checked here. I checked if the return type is position type buy or if it is position type sell. So we are essentially just checking if the currently selected position is a buy or a sell position. And this is important because now I want to check next if the current price, and for this reason, let me get the bid and the ask price here. Wait, we can do it here. Let's get the bid price. It's symbol info double, symbol bid. We did this before. And then let's get the ask price, symbol info double, symbol asked. I don't have to explain anything. We learned this before. And now I want to check. Oh no, let's first of all create some input variables, because we want to say we want to have a TSL trailing stop loss trigger, TSL trigger points, which could be like 200, and then we want to have TSL points, which will then be the distance from the current price where we want to put the stop loss. So with these two inputs in place, we can now use them here. First of all, I want to check if the current bid price is above the position open price of a buy position plus the TSL trigger points multiplied with a point value. And we learned this before, it's the smallest possible price change. Only if this is true, we want to enter this if statement's body. And then we want to calculate the new stop loss. We do so by saying bid minus TSL points, which is the other input that we just created. And I hope that I don't have to explain a lot at this point. I'm just doing simple stuff like declaring variables, putting values inside of these variables, doing some mathematical operations. But we explained this before when we calculated the TP and stop loss for the initial position opening. So then we should, again, it's always a good habit to round these values. And now what I want to do is I want to check if this new calculated stop loss, if it's bigger than the old one. So I want to check if stop loss is greater than this position stop loss, and if this is true, then I want to modify the stop loss. And we can modify a position by using the trade.positionModify function. This is coming from the ctrade object, and we can use it, or ctrade class, and we can use it with our trade variable here. So if we have a look at the parameters, we need the position ticket. This is okay because we have the position ticket already. So let's just use this position ticket. Then we need the stop loss. And this is the new stop loss, which we want to use from now on. So let's use stop loss and then the TP. And here, since we don't want to change this, we will just use the old TP like this. So if we do it like this, this will process the trailing stop for the buy positions if necessary. And we can do the same thing for sell positions. So we want to check if the ask price is below the position open price of the sell position minus TSL trigger points multiplied with point. If this is true, we will enter the body of this if statement, check another if statement directly, and we could combine, we don't check another if statement immediately. We will just, first of all, calculate the stop loss now. So we go ask plus TSL points multiplied with point, and then we round this, and then we check if this new stop loss is smaller than the position stop loss. And for sell positions, this is important. You also have to check if position stop loss is equal to 0. Because if there is no stop loss at all, then the value in the position stop loss will be 0. Because if you request the position stop loss and there is no position stop loss, position get double will return 0. So yeah, if this is true, just the same like before, we'll just call trade position modify, position modify, and we will use position ticket, stop loss, and position take profit like this. So compile, everything's good, and we will run another test in the MetaTrader 5 to just see if our trailing stop is working and if it is dragging the stop loss along once a position reaches X position TSL trigger points and profit. So let's search for a position, and yes, great, perfectly. So this position is 200 points and profit already, I assume. So we see the trailing stop, and the trailing stop should be 100 points from the current price. So, and this is, yeah, it will be 100 points. So if I fast forward the test a bit, you can see as soon as the price drops, the trailing stop will be dragged along, and at some point, of course, it will be hit by the price and the position is closed. Let's check this for buy positions. There's the buy position, stop losses in place, and everything's working just as it should. So this is how you can add a trailing stop. So there's one more thing that you should do if you want to use this program in a live account or something. Because right now, this loop here, it is just processing every single trade in this account because we are going through all the positions. What you want to do is you want to work with a magic number. And the concept of magic number in MetaTrader programming is really cool because we can create a variable for this, which is called magic. This is what I usually call it. You can use any name, of course. It's an integer variable, and the value doesn't really matter, actually. It's just important that if you use multiple programs in your account, you have to use a different magic number for every single expert advisor. Because in the onInit function, we will now go ahead and say trade set expert magic number, and we will set it to this magic number input. Which will mean that whenever this trade object is now used to open a position, this position has this specific magic number. And the magic number is just a number that is stored somewhere in the background of a position. It doesn't change the position at all. It's just a number. But we can read this number from any position. And this is what you want to do in the for loop. So once you selected a position, you want to check if position get integer, position magic is equal to the magic number from the input. And if it is not equal, you want to call the continue statement or operation. And what this does is, you can read it, of course, but I can also explain it to you. Whenever this continue appears somewhere in a loop, it won't process the rest of the body, but instead it will directly go to this code that is processed after the body and then check the condition again. So it will automatically stop processing this current loop run and it will directly proceed with the next one. Because if we have found a position with a different magic number, we don't want to modify the stop loss. You can also, for another safety mechanism, say position gets symbol, and you check the position symbol of the currently selected position. And if this is not the chart symbol, then you also want to continue. So this is what you can add to make sure that your program is not just going mad and modifying every position in the account, but just the ones with your magic number and the chart symbol. And then there's also one more thing, which I can show you if you have a look at this small code here. Instead of writing I is equal to I plus 1, you can also write I plus plus like this. Because this is the same. It's just a short form and it's normalized in a lot of different programming languages. So if you see something like this, you know that this plus plus, it will just increase the value of the variable by 1. So if you compile this, run one more test, maybe the last test, because this is what I wanted to do in this tutorial here. And then we will also see the magic number. I mean, it's not really spectacular, but you will see that there is indeed a magic number for these positions. Like if you go to columns, wait, I don't really see it here, but can we see it for the trades? Okay, you cannot really see it in the tester, but trust me, there is a magic number. Maybe we can see it here. No, but there is a magic number and it will make a difference in the live account if you trade multiple positions or different strategies in your account. So this is pretty much a finished program. So you learned a lot in this tutorial, like variables, data structures, how to use control structures, all of this stuff. So you learned everything. So let's have a look at the code one more time. I will walk you through and then we kind of wrap it up, right? So first of all, we had some properties. Properties don't change the program. They are just the information for the programmer and they are visible here in the overview for your program. Then we had a lot of input variables. First of all, we include the trade.mqh file. This is important, so we have access to this ctrade class to open, modify, and also close positions. Then we have a lot of different input variables. Input variables are pretty much like global variables, like normal global variables, but the user is able to change them. So whenever the user is going here to the inputs, these are all the input variables. If the user changes a value, the program will, from this point on, work with a new value. Then we have some global variables. They're called global variables because they are outside of any function on a global scope. And they are available everywhere in the program, but since they are not input variables, they cannot be changed by the user. Then we have the onInit function. This is the onInit event handling function, which is called when the program is initialized. Here we set the magic number for our program. And we also create the handle for our indicator. A handle is used in MQL5 programming to describe an indicator. And then at some point in your random access memory, this description will be stored and the handle kind of points to this description. So whenever we want to work with this indicator, we can easily access it using the handle. Then also we initialize the bars total variable because this is what we will use in the onTick function later on to figure out if there's a new bar. The onDinit function is called whenever the program is deinitialized. In this program, we don't use it. Then we have the onTick function. The onTick function, first of all, has this source code here, which is our loop. And this loop will loop through all the positions. It will check if this position belongs to a program. Then we will get some properties from the position and the chart symbol. We check if we have a buy position or a sell position. We check if we have to modify the stop loss. And if so, we calculate the new stop loss, check if the new stop loss is better than the old one, and then finally modify the position if necessary. Then we have this piece of code in this if statement here. This is only processed once per bar because we are checking if this bars variable has a different value than the bars total variable. If this is true, we get the ATR value from the last candle using the copy buffer function and the handle that points to the description of the indicator. We store these values in the ATR array. In this case, it's only one value. Also, we get the open and the close price for the last bar. We will then use the open and the close price from the last bar and also the ATR value to figure out if we have a signal. If we have a green candle and a really big green candle, then we want to print buy signal and we want to execute a buy position. If we have a red candle, which is a really big red candle, we want to execute a sell position. Executing these positions works with our custom functions, which we create at the very bottom of our program outside of any of these event handling functions. Functions always have a signature, a name, and a parameter list. The parameter list can also be empty. And then the important part is the body of the function. This is what's actually executed when the function is called. So here we'll just calculate the trading parameters, and then we will just open the position using the ctrade class or the trade object. And we will of course do the same for the sell function in the sell positions. So this is it for the programming part of this video. I hope you learned something, and I hope I was able to explain everything like really in detail and so that you can understand it and follow along. Wow, if you are still here, congratulations. I mean, this was a hell of a ride, I guess. I'm pretty sure you learned a lot about MQL5 programming because I was really trying to explain everything on a really fundamental level, so you understand not only why we do something, but how the computer sees it and why is it having the effect that we want it to have. But actually, this was only like the tip of the iceberg. MQL5 is so powerful, it's capable of doing so much things. In the end, you are able to automate everything that you can think of. If you can describe it, you can automate it. So if you're wondering of right now, like where to go from here, what are the next steps? Of course, you will have to do a lot of things. You will have to practice, you have to write your own expert advisors, and you will really have to reapply these things again and again, so it becomes second nature to you, and it will be really easy in the future to write programs for you. And trust me, again, learning the process is absolutely worth it. Like when I started to learn automated trading or programming, really changed my complete life, and it can also change your life. I'm pretty sure about this. I also have customers who told me that automated trading was super beneficial for them. They are better to automate their strategies. They can provide for their family, friends, and others. And this is all I want to give you like with these videos on this channel. So if you want to learn more about automated trading, it's really important that you subscribe to this channel. Also share it with other friends that you think could benefit from this. And if you want to have if you want to go on the fast track to learning how to write code for the MetaTrader 5 like professionally, again, these were all the basics. And this video, I really put my heart into this to really explain everything like as good as I can. And if you like this style, also you might want to check out the MetaTrader 5 masterclass. It's definitely linked in the description of this video, and you will learn so much more. It's crazy. It will blow your mind. You will learn so many different aspects of MQL5 programming. So not only the basics, but you will also learn more about object-oriented programming, like the stuff we did with the ctrade class. You will learn how to use other functions of the MetaTrader 5, like the calendar function. You will learn how to build complex EAs, complex data structures, how to develop strategies that I use for my live trading for multiple years, that are profitable for multiple years. So yeah, definitely make sure to check out this course. It's, I mean, it can change your life. So what is there more to say? So if you are still sticking around at this point, huge thank you to you for watching the whole video, sticking with me until the end, and I hope that you do not regret it, and I'm pretty sure it made your trading journey better. So let me know in the comments if you watched until this point, and if you appreciate this video, or if you like it, or whatever your thoughts are about this, and if you will stick to automated programming and automated trading. So at this point, there's nothing more to say for me than Thanks for watching, have a good time, good trades, and bye-bye.